Hello, I'm Marcin Konieczny and I am a participant of Summer of HPC in Ljubljana. In this video I want to tell you about my project, which is based on RHadoop and clustering algorithms.
Data production has increased sharply for several years. About 100 million spam messages and 16 million text messages are sent every minute. Every day, we create 2.5 quintillion bytes of data.
My goal was to develop clustering algorithms, which help in big data processing. I work on radiation measurements dataset provided by Safecast. It is a global volunteer-centered citizen science project, working to empower people with data about their environments. The data consists of 90 million of measurements.
In the dataset, we can find such data as coordinates, radiation values and units, or date.
There are many units describing the radioactivity. In my examples, I will use sievert unit.
Exposure to 100 millisieverts a year is the lowest level at which any increase in cancer is clearly evident.
We have contact with ionizing radiation not only during medical examinations. Even bananas are radioactive thanks to their potassium, which contains radioactive isotopes. As you can see, radiation is all around us, however it's difficult to exceed its norm.
For my task, I had a chance to use high-performance computer at University of Ljubljana. HPC nodes contain 12 or 24 cores. I was using RStudio software arranged to work with Hadoop. We can run jobs on cluster directly from the website, where RStudio is able to use HPC resources. I wanted to talk about Hadoop outside, but maybe we could just move back to the class again. Hadoop main component is a name node, a master server that manages the file system namespace and regulates access to the files by clients. There is a number of data nodes, usually one per node in the cluster, which manage storage. With every data node, there are several associated cores, from rescue manager called yarn, for computing purposes. All files are split into blocks, which are stored in data nodes. Another important thing in Hadoop is replication number, which refers to number of copies of particular block in distributed file system. The higher replication number is, the faster software can work in parallel on one block of file.
Map-reduced programming paradigm is an important part of Hadoop processing. Here is the simple example. Map part counts occurrences. Shuffle provides correct data to the reducer, which returns maximum value of the input.
I used Kamin's clustering algorithm to search for coordinates that are close to each other. In each iteration, it calculates new centroid based on mean coordinates value of his representatives. After stop condition, it returns last centroid value and the size of each cluster. Let's start with a simple example. I have loaded 2 million of radiation measurements. Colors of points refer to logarithmic scale. From every map function, I get 100 of clusters. Reducer joins all the output and put it on a map. 1 point is the average of the neighborhood. Let's check how does the map look like with 90 million measurements big file. As you can see, radiation level in many places isn't very high. However, we don't have data from all over the world. You can notice that flight routes have usually higher radiation level. Passengers of planes receive higher cosmic radiation doses.
There are a few places where radiation level keeps high, especially near the big cities and in the damaged nuclear plants areas like Fukushima or Chernobyl. Too much data is sometimes difficult to read. I have filtered cluster centroids with the highest radiation CPM value. Some of the results can be surprisingly high, like this point on the island. I have checked that place on the Safecast website. Only one sensor is responsible for that result. It adds very often high measurements values, which can be caused by a device error.